Our next analysis is about synonym discrimination, and again it is related to disentangling phonological form and semantics, so form and meaning. So we want to discriminate between synonyms which occur in identical context. So let's look at these two utterances: a girl looking at a photo and a girl looking at a picture. And so these two utterances mean practically the same thing. The main thing which distinguishes them is that the form of them is different. So one contains the sequence of phoneme photo, and the other one contains the sequence of phonemes picture. And so if we have a model which is processing the form in such a way that which is processing the input, the utterance in such a way that it discards the surface form and only encodes or strongly encodes the meaning of this utterance, then it should have problems distinguishing these two utterances given here and similar other cases. So in summary, we want to look at how invariant to phonological form is a representation in a trained, visually grounded speech model. So we will extract the representations from utterances such as these, and then we will train a classifier or a series of classifier for each pair of synonyms, and we will see how easy it is to distinguish them for representations extracted from the different layers of the model. And that this particular analysis was done by Ali Shahi et al. 2017. And so we were able to do this easily because the model was trained on synthetic speech, so we could again easily synthesize the stimuli. We could take a picture, we could take a utterance like a girl is looking at a photo, and then synthesize another one which sounds like a girl is looking at a picture, and we could do it for a number of different synonym pairs. So this is a type of analysis which is not particularly straightforward to do just to using natural speech, unless you actually ask people to pronounce these and record it and so on, which is a bit more work than is perhaps worth it. So let's look at the results here in this chart. So in this particular case, we have again the different components of the model on the horizontal axis. So the first point is MFCC, so just a representation of the audio, and then we have different layers in a hierarchy, from the first convolutional layers, which is just subsampling the input and doing a small transformation of it, and then the recurrent layers, and the final one again is the pooling layer using self-attention. So this is exactly the same model as we saw in the previous case study. Just the task is different. But so let's have a look. The error here is this has this U-shaped form. So we see that if we try to do this task on the just on the input features or on the features extracted from the convolutional layer, that doesn't work as well as using the recurrent layers. And then in the final step, when we apply the self-attention and pool, then again the error goes up. So this is perhaps somewhat unexpected pattern, or at least partially unexpected, in the sense that we see that the error for the recurrent layers, even for the fifth recurrent layer, so the topmost recurrent layer, is relatively low, and it only becomes larger after the pooling operation, which is not something that we would necessarily naively expect. maybe you would expect that the representation of form would become weaker earlier in the layer hierarchy. So with some qualifications, we are seeing this pattern that representation of form becomes weaker in the hierarchy of layers, but in this case, it only really happens at the very end.